Hey everybody, this is Larry. This is day 7 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. A little bit late today. My body's been a little bit tiring. Just doing too much physical stuff, and I'm being old. So a little bit late today, but hopefully this week we'll get back on track. Okay, today's problem is 74. Search a 2D matrix. So you're given an n by n matrix, integer matrix. Properly, each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if the target is in matrix, or false otherwise. You must write a solution: O of log m times n times. Yeah, I mean, I think the way to think about this one is, instead of thinking about it as a matrix, because the first thing you kind of notice, or I noticed anyway, is that, as they say, the first integer, I'm hovering against 10. I guess you can't see it. I think someone told me that I could adjust this. Maybe I lied. I don't know how to. Someone told me that I can show the cursor in the new version of OBS, which is why I'm recording this in. But okay, I'll have to look at it another time. But anyway, I'm hovering over the number 10, and yeah. 10 is going to be less than 7, meaning the last item is going to be smaller than or non-decreasing. I guess technically they said actually is greater than the previous row, right? So in that row, you can, instead of kind of you literally maybe think outside the box, instead of having row all number of rows and then columns on them. Just think about it as like almost like a, what's it called? One of those board games where you just basically, but the idea is that it's just a linear array represented in a matrix form, right? So that's basically the idea, I would think. And once you kind of think about it like that, then you can write, just think of this as a binary search, right? So, okay, so let's get started. Let's write out, matrix, right? Yeah, and then, what are we looking? Oh, integer, if it's right? So this is regular binary search. Not gonna do anything too fancy. The way that I want to, I talked about these bounds a little bit. The way that I want to think about it is that these are inclusive. So technically, this goes outside the bounds of the array, which is meant to represent that it is larger than the largest number, maybe, right? So right now we have to define our function of what are we searching for, this binary search function. And yeah, okay, you have a true or false, but you still have to kind of define a function that's monotonic, I guess. You can go true, false, or false, true, depending on how you want to define it, and that's up to you, right? The way that we're going to find it is maybe just like, find the smallest number that is target or greater, right? So then now we can kind of, you have to write in your mind or whatever, so maybe you don't have to write it out, but as soon as you define these kind of functions, then everything kind of falls in place, in the sense that now you can answer in terms of these things. And like way practiced and talented people, they probably do this without thinking anymore, of course. But if you don't, this is where you have like easy off by ones, or like, you're playing with +1, -1, you're like, oh, what am I doing here? And you just kind of jiggle things a bit just to kind of hopefully get it right for the examples, and then afterwards you submit and you get a wrong answer. You're like, oh man, I don't know why I'm having an off by 1 issue here. Well, a lot of it stems from just not a precise understanding of how all the pieces fit together and defining each pieces, right? Each component. So yeah, the way that I always write these is the same way, because like I said, these are inclusive bounds, so that when the range, when your search range becomes one element, then that's your answer, right? So yeah. Oops. So if this is good, and good, of course, in this case, it means that it is indeed the smallest number that's target or greater, then or it is a number that's target or greater, just not necessarily the smallest. So that means that you want to see if there's a smaller number, and mid is good, right? Oh, sorry, right is good. Mid is obviously good, but otherwise we have to try and find a bigger index to see it. And then at the end we just, well, we have to check whether I kind of did this a little bit awkwardly, but yeah, if let's write the good function first. I think the way that I've kind of done this is way, you know, kind of got at it, but yeah. So here you have the index, right? And then now we have to convert it to a new index. So maybe xy is equal to, so what is the x, right? The x is just index divided by, so each row will have c number of items. So that means that we just c and index mod c, right? So then if matrix of xy is equal to, or greater than or equal to target, we just return this then, right? So yeah, it's oops. It's as simple as that. And then now we do it again, right? Of course, if yeah, I guess this way is a little bit awkward, but yeah, if so, left is gonna be the answer. If this is equal to r times c, that means that's our bound, so we return false. Otherwise, we can just check if xy is equal to, and maybe we should have a helper function, but yeah, matrix xy is equal to target, right? Looks okay, so let's give it a quick submit. And yeah, it's not, I mean, there are tricky binary search things, but you should get to a point where, you know, you're able to implement most of the binary search correctly on the first try. I mean, I make this mistake a lot still, so maybe perhaps an idea, but a lot of it stems from me just like rushing it, and this is why I put a lot of focus on really defining what you're trying to do every step of the way. And then when you have all these components, it's almost like, well, you assume this thing returns this thing, but if you didn't kind of define it in a way, then you don't know where to debug and how to fix it and all this other stuff. So yeah, how did I do it last time? I guess last time I did mostly the same. Yeah, but actually, like this time, I mean, you could kind of see, okay, this time I just got lazy, I guess. Or I did it x plus y or whatever, r plus c. But yeah, but you could kind of see that here, I mean, this function is almost the same, but I actually defined it in this case, greater than instead of greater than equal to, and that leads to the things being a little bit different, but same idea. As long as you're consistent about your definitions, everything will kind of follow through. If you have a, you know, if you truly are learning binary search in a good way. Okay, that's all I have for today. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.